There are 5 points some way arranged on the sphere. How many of them can you catch with a semisphere of the same radius? In other words, a villain badly set 5 points. You can see all of them and you want to catch as more as possible with the semisphere net. How many points can be caught no matter how bad the initial setup is? You are free to choose the position of the semisphere. You can rotate it any way you want. If a point lying on the boundary rim, it's okay, you have caught it. I came across this problem in the book by Gardner. He's a great math popularizer, and I think this riddle is the most beautiful problem that can be solved without special knowledge. Are you ready to give an answer? Let's cut our sphere in two. If there are not enough points on one of the semispheres, take the other one. How many points can you catch with this choice? If 5 points are placed in 2 houses, then one of the houses will contain at least 3 points. Pigeonhole principle. Now there are 4 points on the upper semisphere and 1 point on the lower one. So we pick the first one. At this moment there are 2 points on the top half and 3 on the bottom, so we choose the bottom one. There will always be a semisphere with 3 points. So the answer to our riddle is 3, isn't it? Turns out, no. The solution is more unexpected. That's why the problem is a jam. Think a little bit more. Here's a hint. The center of the sphere. Yes, it's not one of the 5 marked points, but it's a more efficient way to use symmetry. Let's construct the diameter cut so it will contain the center of the sphere and any 2 yellow points. Then these 2 points will lie in the first semisphere and on the second one at the same time. Is it always possible to construct such a cut? Yes, there is one and only one plane that goes through given 3 non-collinear points. Without loss of generality, all 5 points are different. Now look at the other 3 points and think about the next step. 2 points are always on the bounding rim, and 2 out of 3 other points will be on the same semisphere, according to the pigeonhole principle. Pick this half of the sphere and we've got 4 points, yup. Let's do it again. No matter the initial point's position, we mark 2 of them. These 2 points with the sphere center define a plane which cuts the sphere in 2 halves. Along with these 2 marked points lying on the both semispheres at the same time. 3 other points can be on the same semisphere, or one of them can be on its own semisphere, and 2 of them on another one. No third possibility is given. That's why we have always got 4 yellow points. But wait a minute, what if I tell you that the correct answer to the problem is actually still unknown for us? We can't be sure that 4 is the right number, and if you think about it, it will be clear that we haven't solved the riddle yet. First, we thought that the answer is 3, but then we found the way to catch 4 points. What if we stopped early and actually the answer is 5, but we've just lost the best algorithm? This question needs a new and elegant argumentation. Look at these 5 points. 2 on the poles, another 3 points are on the equator and form the vertices of an equilateral triangle. How does this example finally solve the problem? The fact is that there is no semisphere that covers all 5 points for the shown picture. It's our counterexample. There is only one circumscribed semisphere of this tetrahedron, and if you want to catch its 4 vertices, you must particularly choose this semisphere. But then the last 5th point will remain frozen on the South Pole. If you pick the bottom semisphere, then the North Pole won't be covered. You can choose another set of 4 points, but not all 5 at the same time. Therefore, we can't catch all 5 points of each arrangement of a billion. but we know how to catch 4 of them. Hence, the answer is 4 and the problem is solved. If you have a question, don't be shy to ask. And if you don't, then I've got one for you. How many points can you catch under the same conditions if there are 9 mark points, not 5? Write your answers in the comment section below, and don't forget about a counterexample. Think critically, do math, take care.